In this video, we'll be going over Chapter 5, Section 2, where we look at ionic bonds. So atoms have a tendency to form ions because they want to get rid of or gain valence electrons in order to get to that magic number 8 that we've talked about in 5.1. So atoms that have 5, 6, or 7 valence electrons are more stable when their number increases to 8. If they have 1, 2, or 3, they're more stable when they lose those and go back down to 0. So we're going to have positively charged atoms and negatively charged atoms when we're looking at ionic bonds. So remember that group 1 has 1 valence electron. They want to get rid of that 1 to get back down to 0. If they get rid of an electron, then that's a negative charge that they no longer have, which means that they now have a charge of 1 positive because they got rid of 1, and so they are 1 positively charged. The ones that have 2 valence electrons, they want to get rid of 2 so that they can get down to 0, so they're going to be 2 plus for their charge. Then we skip over to group 13. They have 3 valence electrons, and if they get rid of all 3 of those negative charges, then they're going to have 3 positive charges. Same can be said for the ones that have 5, 6, and 7. If it has 5, 6, or 7, they want to gain electrons to get to 8, which means they want to gain negative charges to get to 8. So group 17, which has 7 valence electrons, wants to gain 1, so they're going to be a 1 minus charge. Group 16, that has 6 valence electrons, is going to want to gain 2, so they're going to have a 2 negative. And then group 15 is going to have a 3 negative because they have 5 valence electrons and they want to get up to 8. So when you're looking at this, group 1 is a 1 plus, group 2 is a 2 plus, group 3 is a 3 plus. Group 15 is 3 minus, group 16 is 2 minus, group 17 is 1 minus. That's what this chart here is showing you. Okay, so on your periodic table in your notebook, you're going to want to make sure you put these charges because they're going to be really important for creating ionic compounds, which is what we're going to be doing in this lesson. Okay, so if you don't have your notebooks, go ahead and pause your video, get your notebooks, and make sure everybody has these charges written above the groups. Okay, so ionic bonds are attractions between those oppositely charged ions. So like a magnet, a positive is going to be drawn to a negative. And so when we're making ionic compounds, we're going to be bonding something that's in the positives with something that's in the negatives. So we're going to have a left side, group 1, 2, or 13, bonding with a right side, group 15, 16, or 17. Okay, they bond as a form of the result of the attraction from trying to give or take those electrons. And then when they are bonded together, it's called an ionic compound. When they form, it balances the charges. And so when we're forming them together, it's going to sometimes be I need multiple atoms of like lithium, but I only need 1 atom of oxygen in order to get to a 0. We'll go over some examples of how this works, but you can think of it as like if something has a +1 charge, +1 and +1, then you're going to need something with a 2 minus in order for those to even out, because then you would result in 0 from a positive and 2 negatives, then those are going to result into a 0. And so we'll kind of look at how you balance that out in a minute. When we're naming ionic compounds, you first do the name of the positive ion, and then you do the name of the negative ion. The positive ion, you just write the name of that element. So like the example here, magnesium. For the second element, when you have your negative ion, you're going to change the last 3 letters to IDE. So magnesium chloride would be an example. So instead of magnesium and chlorine, it's magnesium chloride. And so you just change the last 3 letters to IDE. Polyatomic ions are ions that are essentially made up of groups, and they react as a group unit. And so any of these that we're using for this assignment, and as you move through doing ionic compounds, we will give you the names for those because it's multiple atoms together of different types of elements, and they have different charges. So if those are being used, then the name will be given to you, so you won't use the element's name from the periodic table. They can be positive or negative, and again, those names will be given to you. So let's kind of break this down and look at how this is going to work. So for lithium oxide, I'm going to do that one in red. So lithium is in group 1, which means that it has a 1 plus charge. Notice that when I'm writing the charge is being written in the upper right-hand corner after my chemical symbol. Oxygen, remember it says oxide, but that's because the last 3 letters changed to IDE, so it's oxygen. Oxygen has 6 valence electrons. It's in group 16, which means it has a 2 negative charge. So when you look at this, Li has a 1 positive charge, and oxygen has a 2 negative charge. In order to even these out, I'm going to need Li1 plus and Li1 plus and oxygen 2 minus to have 2 positives and 2 negatives, right? So when I write out my chemical formula for this, I'm going to say Li2 to show that there are now 2 of them, and O to show that I only need 1 oxygen. So I'm going to have lithium, lithium, so it makes Li2, and then I'm going to have just 1 oxygen because since that has a 2 negative charge, the 1 plus and 1 plus evens out when you have a 2 negative. Okay, you can also do the crisscross and drop trick. So if I have Li1 plus and O2 minus, if I take these and I crisscross and drop them, I crisscross means that I'm going to write them on the other element because I went the other direction, and drop because I'm going to now make them the subscript. So when they're the charge, they're in the top right. When they're the subscript telling you how many of that element happens, they become lower and to the right. So you can take essentially the number here, crisscross and drop. So this became a 1, but you don't have to write it when it's a 1. This one had a 2, crisscross and drop, so it's Li2. So let's do another example of that. So sodium sulfide, we'll do in blue over here. So sodium is Na. Sorry, I'm going to have to write small. Na. And that has a 1 plus charge because that is in group 1. And then sulfur has a 2 minus charge because that is in group 16. And then we're going to do the crisscross and drop. So if I crisscross and I drop, now I have Na and a small 2, and then S had a little 1, but you don't have to write it when the 1 is there. So again, I took this, crisscrossed it to the other element and dropped it as the subscript, took this charge, crisscrossed it, and dropped it as the other one. And this works out the same way where I would have +1, +1, and a 2 minus that needs to be evened out. So lithium oxide, we said, was Li2O. Sodium sulfide is Na2S. All right, aluminum chloride. Aluminum has a 3 plus charge because it is in group 13. Whereas chloride, which is chlorine on here, right? Chlorine has a 1 minus charge because it is in group 17. So if I crisscross and drop those, I'm going to end up with, if I take them and I go whoosh, I'm going to end up with Al1, but again, you don't have to write it when it's a 1, and then Cl3. You can look at this when you're looking at the charges. We had 3 plus, and then we had 1 minus, 1 minus, 1 minus. So see how that makes 1 aluminum that we need, and 3 chlorines, because then we would have 3 minuses, so that these even out. Okay, so this is the logic behind it, and the crisscross and drop is just an easier way to do it. So you take this, bring it over and drop it. Take this, bring it over and drop it. Again, when you're writing the charge, it's small and to the top, right? When you're writing them in the answer, it's a subscript because it's telling you now how many you need. So it's small and to the right. AlCl3. All right, the last one we have is sodium chloride. Okay, so we're going to do that one. I'm running out of room. We'll do it right here. So sodium we said was Na1 plus because it's in group 1. And chlorine we said was Cl1 minus. So when they have the same number like that and you crisscross and drop, you don't have to write any of the numbers because when they have the same number, it's just going to cancel out. So NaCl is going to be your number. So if they both had a plus, like a +2 and a -2, or a +3 and a -3, either way, you don't have to write the subscript numbers down here if they have the same number in a charge, just opposite. So 1 plus and 1 minus, 2 plus and 2 minus, 3 plus and 3 minus are going to all be written just as the two elements. Okay, this wraps up 5.2 where we're looking at ionic bonds.